This problem is called racing a car, and it is Leetcode problem number 818, and it has been asked in Google and also Amazon interviews, and it's a hard problem. So please pay attention. So first let's understand the problem statement. So in this problem we have a car. So there are certain rules that the car needs to follow. One is that in the beginning of time, if this is the x-axis, this is position 0, x equal to 0. So this is the initial position at time equal to 0. And also its speed is plus 1. That is speed in right direction. So right direction we will take as positive direction, and in left direction we will consider the speed as negative. So initially this is the case. So there are two possible actions that you can perform on the car. So this car is automatic and you can only either press button A and R. This is not a typical car, but let's say for this problem statement, these are the only two functionality that you can perform. So when you press A, so at any point of time car will be at some place and with some speed, so some x and some speed v, or let's call it speed only. So whenever you press A button, then it will add whatever is the speed to the position. So let's say it was at some position which was 10 units from here, origin. So its position was 10. Let's say at that point of time the speed was 5 plus 5, and you press A. Then what it will do, it will add the speed to position. So its position will become 15. So car will come here and position will become 15. And also its speed will get double. So whenever you press A means accelerate. So whenever you press A, its speed doubles. So speed will become 10 instead of 5, and the position will become 15. If you press A again, it will again add the speed, that is 10. It will come here. It will become 25 and the speed will become 20. But when you press R, that is reverse. So R is reverse, A is accelerate. So when you, let's consider this scenario again. The car is here and we press R. So what will happen? Its position will remain here only. Only thing is that the direction of car will change from right to left. So speed will become -1. So in order to reverse, first you need to stop the car and then reverse. And initial speed, the minimum speed is 1. So here what will happen? It will stop, change the direction and assign the initial speed, that is 1. But in this case direction is right to left, so it will be called -1. And position will remain same. If the speed was negative, that is car was already in this direction, then its speed will become +1. That is, it will stop, it will change the direction and get the initial speed of 1. So these are the two actions. Now based on these two actions, you have to reach certain target. So target will be in positive x direction, and you have to perform only these operations A and R. So the question is to find the minimum number of operations required. There may be multiple ways of reaching the same target, but you have to find the minimum number of operations, and the operations possible are A and R. For example, for target 6, the operation can be AAA R A. Let's see how. So our target is 6. Let's say 6 is here, 0 is here. Car was initially at this position, origin, and facing in right direction with a speed of +1. So in order to move ahead, so position is added or position increases or changes only with the action A. So first thing you need to do is to perform the action A. You will not perform R because your direction will change and you will get far from your target. So this is the first operation. So speed was 1. So now position will become 1. So this is position x and this is, let's say, speed. So speed will double due to A. Now you are at 1. Still you are far from target. So you press A again. So whatever was the speed is added here. So your position becomes 3. So let's say 3 is here. So this distance was 1. Previous speed, this distance is 2. The next speed, and the speed doubles. So speed becomes 4. So you are halfway down there. So next time if you press A, this speed 4 will be added and the position will be 7. So your car will reach here at this position, white spot, this is 7. So you have overshooted your target, and that's fine because you can always reverse. So you are very close to the target. Now you will not go further because next time here at this point of time your speed is 8, and if you press A again you will jump to 15, and you will have to again reverse the direction, come back. So that will be wasting of operations. So you stop here and then you reverse. So for reversing you need to press R button. So at this point of time the speed was 8, so now it will change to -1, that is left direction. Next you perform A. You will never perform 2 times R because first time you perform R your car direction changes from right to left. If you again do R, it will again change to right. So you only turn back to go back, and now you are back to the original direction. So you will press R only once. Now the speed is -1 and position is 7. You need to reach 6. So what you will do, you will press A again here after R. So the position will be added. So 7 plus speed will be added, sorry. So whatever was the speed, by pressing A the speed is added to the position. So position becomes 6 and your car comes here, the target, and the speed is -2. But you have reached the target, so you will not be worried about speed. So the number of steps are 3, 4, 5. So the answer should be 5, AAARA. So you don't have to return the exact sequence, you just need to return 5. Now let's see how you can achieve it. So this was one of the ways, like you went past the target and then changed direction and came back to the target. So in this case what you were doing, so let's say speed car was the function which takes target as input. So what you did, how is your position increasing? So initially by performing one action you add 1 to the position. Initially it was 0. Then again you press A, you add 2 to the position. If you again press A, you will add 4 to the position because the speed is always doubling. So you can think of binary numbers. Then if you press A again, you will add 8 to your numbers. So it's increasing in this fashion. So if you write in binary, this number is, so initially your position was 0, all 0. I am writing now in binary. Then by adding 1, it becomes 0, 0, 0, 1. By adding 2 to the current position, it will become 1 plus 2. That is, you add 1 0 to this number, so it will become 1 1. Then it becomes 7, that is 1 1 1. Then it becomes 15, that is 1 1 1 1. So you are adding always powers of 2 when you are performing a series of A operations. Okay, so in this approach we overshooted and then returned back. There is another approach where you stop just before overshooting. For example, in this case, till position 3 you are before you have not reached target, and next time you press A you go past the target. So you stop here itself, and then you turn back to take a few steps back and then perform a few A operations to reach target. So maybe this is this way of doing reaching the target takes lower number of operations, but we don't know beforehand which will take lower number of operations. So we will compare both, we will solve for both the ways, that is overshooting the target, coming back, and stopping just before the target so that it doesn't overshoot. If the target was 7, then we would have exactly reached the target in one go. That is another case, but that will not happen too often. So either you overshoot or you stop just before overshooting and then turn back, take some steps, turn back again and take some steps to reach the target. So let's first reduce our problem size using the first way, that is overshooting the target. So we stop just after the target. So in this case you see that the positions are added as a powers of 2. So here it will be added 3 times, 1 plus 2 plus 4, then it overshoots. That is because the positions are always like in the form like 0, 1, 1, 1, 1, 1, 1. So we are looking for 1, 1, 1, which is more than the target. So in this case 6 is represented as 4 plus 2, that is 1, 1, 0. So it is 3 digits longer. So after 3 steps you will overshoot it. So you can find the number of digits in the target using log 2, log base 2, 6. That will be 2 point something, and then you can take one more. So you can take the floor. So you can take log target, log base 2 target, take the floor and add 1 to it to get the exact number of digits in the target. So here what you did, you reached at a position 2 raised to the power of, so let's say this number of digits is n. 2 raised to the power of n minus 1, this is 7, in this case for n equal to 3. And then when you reach 7, your distance from target has reduced. So originally you were at 0 and target was at 6. So distance was 6 from your position to the target. Now you have reached close to the target. You have just overshooted. So now the difference is, we can say 7 minus 6, that is 1, 2 to the power n minus 1 minus target in general. So this is the new difference, distance. But your car is moving in right direction and the target is behind. So you need to turn back. So what you perform n times a to reach this position 7. So you write, you find, so let me write the function again. So we have sc is the function name and target, let's just call it t. So what you did, you found the number of digits which was log base 2 of target and you take the floor plus 1. Then number of operations is n plus, you need to reverse. So one operation for reverse and then the same function sc 2 raised to the power of n minus 1 minus target. So we are calling the same function recursively with smaller target. But this was just one way where you always overshoot the target and then return and come back. The other way was to stop just before target. So you take just n minus 1 steps. So if in nth step you overshoot, then in n minus 1 step you will be before the target. Also you need to add a base case where this exactly becomes equal to target, then you return. So you take n minus 1 times a, then you add 1 step to reverse, and then you take a few steps here. You don't know how many steps, that is some variable I which we will arrive at, and then you have to turn back again because the target is on the right. So you again perform reverse, and now it's same as original problem. So your car is facing in the right direction, the speed is plus 1, and whatever is the distance from this to the target is the final distance. So now you can call sc on that thing, and that was here target is to the right. So target minus 2 to the power n minus 1 minus 1. So you came this close to the target, so this is that distance, t minus 2 to the power n minus 1. Then you turn and move a few steps to the left, so that increases the distance, so plus 2 to the power I minus 1. And I we have not defined, so we have to look for all the possible values of I from 0 to this n minus 2. We will not go back n minus 1 because we will again reach origin. So 0 to n minus 2, and we will take minimum of these. So minimum of this first approach, and the second approach again looped over all the values of I. So let me write it again. So SCT so we can find the number of digits first. The function is log2 t, and we can take the floor function. The function name is also floor in C++ plus 1, and then we check if 2 raised to the power n minus 1 equal to target, then simply return t. Else this is not the case, then what we will do, we will set result equal to this thing, n plus 1 plus the same function on 2 to the power n minus 1 minus t, the new distance. And then what we will do, the other approach, this was the first thing where we overshooted. For the second case, we take I equal to 0 to n minus 2. So result equal to minimum of result and this thing n minus 1 plus I, so this one gets cancelled, so n plus I plus 1, n plus I plus 1 plus the same function t minus 2 to the power n minus 1 plus 2 to the power I minus 1, again this minus and this minus, these one get cancelled, so t minus 2 to the power n minus 1 plus 2 raised to the power of I, and finally we return the result. So this is a recursive way of writing it, but you can notice that it can explode exponentially since we will be solving it again and again. So let's say we have t. So for finding the t, we want 2 raised to the power n minus 1 minus t, and we also need t minus 2 to the power n minus 1 plus 2 raised to the power I, and this I can go from 0 to n minus 2. So there will be multiple overlaps here. So instead of solving this, maybe that this SC function was, or its drive car, so this drive car function was already solved for that value. So this is a typical case of digital or dynamic programming, sorry. So let's save the results. So let's modify it. So our function is sct, and then the same thing, find the value of n, and then define a array of size t plus 1. Let's say it's initialized to some negative value, and then we check if this solution exists, that is it's more than or 0 greater than equal to 0, then simply return it, because initially it was minus 1. Return dpt. If it's not the case, then we will find the value of n equal to floor of log 2 of t plus 1, and then we set dp of t equal to take n steps to the right and then one step to reverse and then come back to target. And then the other approach, so this was the approach where we overshoot. The second approach is to stop before, so instead of n operations, n a's, we do n minus. So this is the case for n times a followed by reverse, and the other case is stop before, that is n minus 1 times a. So we will do for I equal to 0 to n minus 2. So in this case we came to n minus 1, so we will not go back n minus 1, so that's why. So dpt equal to min of dpt, the existing dpt, and this operation n plus I plus 1, n plus I plus 1 plus sc t minus 2 raised to the power n minus 1 plus 2 raised to the power I, and finally we return dpt. So now what is the time complexity here? So this by the way, this dp array, this was a one-dimensional array. It was denoting how many operations, how many minimum operations are required to reach from 0 to that position. So dpi, if you say, denotes the minimum number of operations required to reach from 0 to ith position. So finally we are returning t, that means reaching from 0 to target position. So the time complexity here, this array length is t plus 1, and we are solving it t times or t plus 1 times, and for each we can go back. We have to try different values of I, which is similar to of the order of the order of n, and n was nothing but number of digits, and number of digits is nothing but log of t. So t times number of targets, that is the target value, t times log of t. So this is the time complexity. And the space, we are using an array of length t plus 1, so space is of the order of t. Now let's write the code for this in Leetcode and see if it works. So we have this vector of int of length target plus 1 and initialized to -1, and we are calling this function recursively, but we are initializing it only once, so we can make it static or you can make it global, and then number of digits. So if we perform NA operations and it exactly reaches target, then we can simply add t equal to n, else we will perform the first operation, that is overshoot, that is n A's, then 1 reverse, and then raise car 2 raised to the power of n minus 1 minus target. And then the second approach, so for that and finally return dpt, and we forgot to add this case here. If this already exists, so dpt is greater than equal to 0, then return this value. Now let's run. So here it's target and not T. So if you run with this, it's fine, it will work, but it says heap buffer overflow, if you see here, and let's see why is that. It's showing for 6. So one thing is that here, why is this 2? It should be n. Let's see. So it works now for 6. Let's try to submit. And it says address sanitizer heap buffer. Again some error. And it says the input was 6. So it may be possible that in Leetcode it's running this function again and again. So instead the target will change every time in every run in the Leetcode. So it may be that it's running this static thing only once for all the test cases. So their target lengths are different. So better to add a big number. In this case, it's given that our target is less than equal to 10,000. So let's see. So it should have the sufficient space for any target, but if we make it target plus 1, then it's possible that since it's a static, it will use the same target of whatever was the initial target length. So it will throw error. Now let's run with this. And the solution is accepted, and if you see, it's better than let me drag it. So it's better than 94.11%. If you run it a few times, you may even reach 100%. So now it's accepted. So this was specific to Leetcode. So I hope you understood the solution. If not, try understanding the logic again. It's a hard problem, so it may take some time. And the time complexity you can see is that this loop can run for n-1 time, and n is number of digits, which is log of target. So t times log t.